All right, I need someone to read our objective to get started. Thanks, Sequoia. All right, so when we look at that objective, I can add fractions with like denominators. What does it talk about what does it mean, like denominators? Or actually, talk at your table for about 30 seconds. Go.
It means similar denominators. Like denominators.
All right, back up here.
Denominators.
So when we're talking about like denominators, what are like denominators? Bella? Yeah, the same denominator. So when something is like each other, they are the same. Okay? So we're going to start off with this study jams step by step. And really, when we're adding or subtracting, so we will look at adding and some subtracting today. But we've already kind of done this. With what kinds of fractions? Yeah, tenths and hundredths, right? So same rules apply, but now we're just using fractions that don't have the denominator of 10 and 100. Okay? Yeah, I think we've done this.
On the class camping trip, Zoe and I practically lived at the rappelling wall. We had to get back for lunch, so we looked at the map to see how far it was to get back to the mess hall. We know it's 4/10 of a mile to the cabins and another 2/10 of a mile to the mess hall. Let's add up these fractions to find the total distance step by step.
So when we look at this word problem, they're going from the rappelling wall, the rock climbing wall, to where?
The mess hall.
Yeah, to the mess hall. So they know that it's 4/10 of a mile to the cabin, and then from the cabin it's 2/10 of a mile to the mess hall. So we need to, we're going to add.
The first step is to line up the problems horizontally.
So just like when we've added fractions like we just said with tenths and hundredths. So we still follow that same process. We're adding them horizontally, okay?
You got to make sure the numerators and the denominators line up.
So just like any other problem, like when Jaheem did our multiplication at the beginning or for morning work, and when you're doing addition, subtraction, whatever, you need to make sure that they're lined up. Fractions, same rules.
Next, add the numerators across.
So when we add these numerators across, 4 plus 2?
6.
Yeah, we're going to get 6.
4 plus 2 equals 6.
So now remind me, what's the rule when we are adding fractions, or subtracting fractions? Kaylee, what's that rule?
The denominators have to be the same.
Bingo. Yes, the denominators have to be the same. So what's our fraction? What's our sum?
6.
Yeah, 6/10.
Now, place the sum of the numerators over the denominator. The denominator is 10, so the fraction is 6/10. Finally, write the fraction in simplest form.
Simplest form comes back around again. What does it mean when you put something in simplest form? What is simplest form? Harrison.
Simplest form is taking a number and making it smaller.
Okay, so we're making not just the number smaller.
The fraction.
Yeah, the fraction smaller, but it's really an equivalent fraction. It just is using smaller numbers, okay? So think about 6 and 10. What is a number, and talk with the people at your table, what is a number that you can divide 6 and 10 by? Go.
A number you can divide. We know it's equal to 6.
All right, go green. Okay, so what can we divide 6 and 10 by? So what would be the greatest common factor? Natalie?
4.
All right, so let's check. So whatever I do to the top.
I do to the bottom.
Okay, what's 6 divided by 4?
Nothing. 1 with the remainder of 2.
Well, is it going to be a whole number? No, it won't be a whole number. So let's go back to the drawing board. Let's think about it again. Maximus, what did y'all come up with? 6. So whatever I do to the top.
I do to the bottom.
Okay, what's 6 divided by 6?
1.
1. 10 divided by 6.
Can't do it.
Okay? I can do it, but I can't get a whole number. Okay? I would have a remainder. So let's try it again. 6 and 10. Tristan. Okay, let's try 2. Whatever I do at the top. Okay, 6 divided by 2? 3. Okay, so remember when we're simplifying, your factor has to divide evenly with both your numerator and denominator. Okay, because like we just said, whatever you do to the top,
You gotta do it to the bottom.
gotta do to the bottom. All right, let's see if we are correct.
Both 6 and 10 have the factor 2 in common. The simplest form of this fraction is 3/5. Looks like we have to walk 3/5 of a mile to get over to the mess hall. I think we have time for one more rappel.
All right, good job. So
Find the sum of these fractions.
So when we look at this equation, okay, so I have 2 ninths plus 2 ninths plus 2 ninths. Do you know how to add 3 whole numbers together?
Yes.
Yes. So if you can add 3 whole numbers together, you can add 3 fractions together, okay? So when I look at 2 ninths plus 2 ninths plus 2 ninths, thinking about what we just learned, or the strategy that we learned when we add these fractions together, what are we adding together when we look at this equation up here? What do we add together? Alice.
2 plus 2
Yeah, 2 plus 2 plus 2. What do you get? Yep. 6. My denominator.
27.
Is it 9 or is it 27? Tristan, say that again.
The denominator has to stay the same.
Denominator stays the same, so I'm going to have 6 ninths. Look at your answer choices, though. So if 6 ninths isn't an answer choice, this means what do we need to do to this fraction? What do we have to do? Sequoia? Yeah, we need to simplify this fraction. So again, talk with your team. What number can you divide 6 and 9 by?
That she gave me.
Sit up. Alright, so talk to me. What number can I divide 6 and 9 by? So what would be a common factor? Ayana, what did you guys come up with? 3. So let's try whatever I do to the top. How to do to the bottom. 6 divided by 3? 2. 9 divided by 3? 3. Ah, is that an answer choice? Yes. So we have 2/3. Let's see.
Good one. 2/3 is the correct answer. 2 plus 2 plus 2 is 6. When we reduce 6 ninths to simplest form, we get 2/3.
Good job. Alright, now the next one, it's not going to necessarily go with our objective, but we're going to try it anyway.
Find the difference of these fractions.
So now difference. Difference is a keyword for what operation? Subtract. So we have 5, 6, subtract 2, 6, subtract 1, 6. So what would I do? What do you think I need to do based on what you know about addition? What would we need to do? Bella, what are you thinking? Okay, so subtract 5, 2, and 1. So if I start with 5, 5 subtract 2, Tristan? 3. And then Jabari, 3 subtract 1? Yeah, 2. So that's my numerator. What's my denominator? Okay. Okay, so now 2, 6. Is 2, 6 an answer choice?
Yes.
It is. However, think about it. Can 2, 6 be simplified? So you want to know a trick or a hint? So what do you know about these two numbers, about 2 and 6? What kind of numbers are both of these numbers? Don't shout it out. And what kind of numbers are these? They're even numbers. So what do you know about every single even number? Sequoia? Yeah. So they're a composite number. So they have more than one factor typically. But yes, 2 is a prime number, but 2 is also even. So all even numbers can be divisible by what? What number? Lacey, what you say? Yeah, 2. Can you take an even number and cut it in half evenly?
Yes.
Yeah, so all even numbers are divisible by 2. So 2 divided by 2? Jahid?
1.
6 divided by 2, Jahid?
3.
Yeah. So 1/3. So I just want to show you. Let's look on 2, 6 and see.
Sorry, try again. Make sure your answer is in simplest form.
So is this in simplest form 1/3?
Yes.
It is, yes.
You got it. The difference is 1/3. 5 minus 2 is 3. Minus 1 is 2. 2 over 6 can be reduced to 1/3.
Good job. Okay, so we're going to take this one step further and look at some word problems with addition, and we might do some subtraction just to throw them in there. So while I'm getting this up, on your table, there should be enough, just like yesterday with fraction tiles, there should be some fraction tiles for you to use with a partner or a group of 3. Now, wait. For this next thing that we're doing, you will only need your 6 and your 8. So you can get all your 6 tiles and your 8 tiles out, and then show me you're ready. If you need fraction tiles, they're back there on the counter. Yes. Yeah, just get off now.
So we're normally
Huh?
adding these.
We're normally adding them. We are going to add them. We're going to do some subtracting.
Yeah.
Yeah, we do too. Do you guys have... How many of those do you have? 7. Do you have another one down there? Yeah, you do. Right there. Am I missing an 8? Do you have 8? 8? Do you have 8? 8? Do you have 8? 8? Put the rest of those away. You guys have 8? 8? You guys have 8? 8?
1, 2, 3, 4, 5, 6, 7, 8.
You agree? Okay. So the rest of your tiles, you can just put them to the side for right now. You will not need them. We're not playing with them. Okay, so while we're reading these word problems, we're going to do the first one together, and then I'll let you work with your partner on the rest, and then we'll check them together, okay? So when we are working on these word problems, we need to do the following 2 things. We need to identify what the problem's asking, of course, and then identify of any keywords that we see to help us give a clue of what operation we're using, because these could be a mix of addition and subtraction, okay?
I think I'm going to do multi-step.
Yeah. All right. Cashton and Devontae were playing a video game and trying to get all of the treasure. Cashton got 1/8 of the treasure. Devontae got 5/8 of the treasure. together, Cashton and Devontae got what fraction of the treasure? So what's a key word that you automatically see in here that gives you a clue of what we need to do? Eliana, what do you think? Together. So what is together? Give us a key word of the operation that we need to do. Kaylee? Yeah, addition. Okay. So let's model first how much treasure Cashton got. So how would I model that using my fraction tiles? Sequoia? Okay. So I have here Cashton. Now the next person is who? Devontae. And how much treasure did he get, Tristan? 5/8. So we're going to drag 5/8 over here. Careful. So you're doing this with me with your fraction tile. Like you put the rest of those to the side. All right. So we have Cashton and Devontae. Now, Eliana told us that when they put them together, together is a key word to do what? Add it. So if I add these together, what's my total? 6/8. Now, if I'm writing this as an equation, so I have 1/8. What am I adding to 1/8? 5/8. And I add that together, and I would get 6/8. Okay? Pretty easy?
Yeah.
Okay, good. Yeah. You can. So let's talk about that. So 6/8. How could I simplify 6/8? Talk with your teammate. How could you simplify 6/8? What would be your simplified fraction? What can you divide your numerator and denominator by? 2. So whatever you do at the top. Okay, so look at that again. Think about what I just told you. Here. So if I have 6/8, what did you figure out was your GCF, your greatest common factor?
2.
Okay, 2. So if I divide 6 by 2, I get what? 3. 8 divided by 2? 4. So 3 points. Good. All right, next one. All right, next one. You will work with this one with your partner. So you give 2/6 of a pan of brownies to Layla and 1/6 of a pan of the brownies to Hunter. How much of the pan of brownies did you give away? Give you a hint. You need to look very carefully at this problem and the wording of it. Okay, I would like to, before you solve, 2 things. I want to see how you're modeling it with your fraction tiles. And then I'll come and check in with you. I want to know what your equation would look like. Okay? Go ahead, solve, go. Sure. Go ahead, solve.
The equation is 2/6 plus 1/6 equals 3/6 simplest form is 1/2.
No, but
3/6. But
It just kind of worked out. Look at that again. Very carefully. Think about what it's asking. All right, so talk it through. Yeah, that's part of that. Eliana, go ahead. So show us with my fraction tiles, and then you explain what you and Caleb did.
And write the equation.
So 2/6 is Layla. So you gave away 2/6 to Layla. And you gave away 1/2 or 3/6.
Okay. Did anybody solve it a different way? So she took the amount that you gave to Layla and the amount that you gave to Hunter, and they added those together. Did anybody solve it in a different way? Sequoia, did you guys solve it a different way? Okay. Do you want to come here and solve? Huh? Why? Okay.
Then just pop it out.
Did any group talk about your full pan of brownies, and did you subtract it from your full pan of brownies? So what would your full pan of brownies look like? What fraction would you have with your full pan of brownies? Start calling out. But yes, 6/6. Okay. So if this is my full pan of brownies, what could I do with this to show that I'm subtracting or I'm giving away? Tristan?
Add 2/6 plus 1/6, and you subtract 3/6 minus 1/2.
Miss Reynolds?
Yes, ma'am.
Yeah, just being found out.
All right, thank you. Stella, go ahead. So Tristan, you're kind of on the right track, but if I have my full pan of brownies, what does the word problem say, Lacey? What does it say? How many did I give to Layla?
2/6.
2/6. So what could I do with this? Yeah. Take it away. Okay. Now, what else do I need to do? Chase, what else did I give away? To Hunter, right? So now I can take 1/6 away. So now, what happens with this problem? Is this the amount that I gave away? Or is this the amount I gave away?
It can be up and down.
Yeah, in this problem, it just kind of works out to where it was an even amount. But this was the amount that I took away. So if we started with our whole and subtracted what we were giving away, then we would get our answer, which is, as Eliana said, what? Yeah, 3/6 or 1/2. Okay. All right, one more, last one. All right, this one. Carson walked 4/8 of a mile to school. Lily walked 7/8 of a mile to school. How much farther does Lily walk than Carson? Okay, go ahead. Solve. Same two things. Model and equation. Lay them out there so you can see. Back there. Maybe. Think about what it's asking.
We didn't have enough, so I had to use the 6.
You have enough. Look at it closely.
I know, but we got 4/8 of the little 1/2 goes for 6, so I just use those.
You don't need more than 8.
I know, but I like to use those.
Yeah? So it's asking how much farther does Lily walk than Carson. This is not a model to me. I need to see it modeled.
Did you give me that?
Okay, I need to see your model.
Miss Reynolds, there's our model. Right there. Could you please give me that? Hey.
Are you helping him? Yeah. Does it work?
Will that still be okay? So 4 subtract 7 equals 3, and you cannot subtract these. So and you cannot simplify it. So it's 3.
All right, good green?
No.
All right, so let me get these fraction tiles out of here because I have my 8. So I have all my 8. Do I need all my 8? Not necessarily. So let's look at this. Carson walks 4/8 of a mile. Lily walks 7/8 of a mile. So how much farther does Lily walk than Carson? So if I start off with my 7/8, right? Who does this represent?
Lily.
Yeah, thank you, Tristan. So let me redo that. So this is Lily, right? Okay. So how far does Carson walk? Could I show it using these same fraction tiles? Yeah, so how many would I need to identify that Carson walks?
All you have to do is
Guys, the answer's right here in the problem. How far does Carson walk?
4/8.
Yeah, 4/8. So if these are Carson, what's left? What does this amount show?
3/8.
Yeah, it shows 3/8, but it's showing the difference in how what?
how much farther Lily walks.
Yeah, how much farther they walk. What would your equation look like? Donovan and Kaylee, what would your equation look like? Yeah? 7/8? 4/8. Say your numerator first. Yep. And what would your difference be? Yep. 3/8. Okay. All right, good job. So, when we are adding or subtracting, same rules apply. We look at our numerators and we follow our operation. Denominators do what?
Stay the same.
Stay the same. Okay. So here's what I would like for you to do. Go ahead and put your fraction tiles back in your baggie. One person from your group can take it and put it back in that baggie in the back counter, and then wait and listen to my directions.